Hello everyone, welcome back to the Saga Tech Gates. In this video, we'll explore a behavioral modeling in Verilog, one of the most powerful and intuitive way of describing a digital systems, like by using always, if else, case structures. Okay, if you are just starting with a Verilog or digital design, this is where the magic of algorithm meets a real hardware. Let's get started. Behavioral modeling. So this is the highest level of abstraction provided by the Verilog HDL. We discussed gate level data flow modeling. Compared to those modeling style, it provides highest level of abstraction. We'll use a simple construct like if else statement to describe the behavior of the circuit. So the designer described the behavior of the circuit instead of how many gates are there, how they are connected, like gate level modeling. So at behavioral level, a model is described using algorithms without concern for the hardware implementation. So we are not worried about what are the components used in that, how they are connected. Without concern for the hardware implementation means without concern that internal structure of that circuit. Just we'll use the algorithm to describe that behavior. So it describe how a digital system behaves instead of how it constructed. So by using always block, if else statements, case structures, loops and more, we'll use these simple constructs to describe the behavior of the model in a behavioral modeling. So in Verilog, behavioral model contains procedural blocks. If you want to describe the behavior of any digital circuit in terms of model, we'll use the procedural blocks. So we have a two type of procedural blocks, always and initial. So always use it for a designing purpose. So that initial is only for test bench purpose. It is not synthesizable. So always we'll use this always construct to describe the behavior of this digital circuit in a behavioral modeling. So these blocks describe how the system behaves over the time. So rather than how it is physically interconnected. So if you see in Verilog behavioral model contains the procedure block. What is mean procedure block? A procedure block is defined as a region of code containing a sequential statement. They execute in the order they are written. So whatever the statement written in this procedural block are the sequential statements. They will execute one by one. They execute one by one in the order they are written actually. So we have a two type of procedure blocks. One is always, another is initial. So this always block execute forever. So execute whenever sensitivity list changes. Along with the always block will provide some sensitivity list. Based on the sensitivity list, nothing but it contains some signals. Based on that sensitivity list, that always will trigger. It execute forever continuously. Whenever the sensitivity list changes, then it will trigger and it will execute. So another procedure block, we have initial block. So execute once at the beginning of the simulation. So it is not for a designing purpose. It is just only for simulation, like especially used in the test benches. Clear? So it execute only once at the beginning of simulation, and whereas the always is execute continuously. Whenever the sensitivity list changes, then it will execute. Where initial will execute only once at the beginning of simulation time, at zero simulation time, we can say. So a model can contain any number of procedure blocks, all of which execute concurrently. The model contain maybe n number of always blocks. All always blocks will execute concurrently. The statement written in this always and initial blocks are sequential. So like those are the procedural statements, blocking and non-blocking statement. We'll discuss about this statement in detail in the coming lectures, right? So here just the model may contains n number of always blocks, but all always block will execute concurrently. Each always and initial block represent a separate activity flow in the Verilog. Each activity flow start at a simulation time 0. So each and every always and initial represent some activity flow in a Verilog. So these activities starts at a simulation time 0. So always and initial cannot be nested. We cannot write one always block inside of another always block, or maybe initial inside always block. So we cannot nested these always and initial blocks. So here I'm not discussing much about always and initial. Just I want to convey. So in case of if you want to write Verilog code, especially if you want to describe a model by using behavioral modeling style, we'll use these procedure blocks. and we'll use some simple construct like if else and case structures like that. So I want to convey that only. So always and initial will discuss in detail in the coming video lectures. So now see, I'll give some example how to write behavioral modeling style of Verilog code. So this is a off adder having a two inputs A and B and two outputs sum and carry. Now see here, this is the truth table. So we know that sum is XOR of this given input, whereas the carry is the AND of this input. Just you can write expression sum is A XOR B and carry is A and B. If we know this, okay, so we are not bothered about what are the gates used inside, how they are connected, okay, how the data is flowing from input output. It doesn't matter. Just we'll write that directly this condition here, like this expression. So now I'll define one module name. These are the port list. I'll declare both A, B as the input, whereas the sum and carry as the output, that to reg type. Already we discussed about reg and wire in detail in the data type Verilog video. So better you watch it before seeing this one. Okay, if you want to use any signal as LHS in this always or initial, it should be a reg type. This is a thumb rule already we discussed. The LHS in always or initial, the LHS in the procedure block should be a reg type only. Okay, whereas the continuous assignment type, that LHS should be a void type. Now see, input A comma B, output reg sum comma carry. So always at the rate A comma B. So now we'll discuss about always and initial later. To understand this code, I'll explain this statement. So at the rate A comma B, this is known as a sensitivity list. If A changes or B changes, then it will trigger and this always block will execute. Whenever A changes or B changes, then it will execute. So always at the rate A comma B. This is meaning if A or B changes, then will execute these statements. The statement written in this always and initials are sequential statement. Not only that, in Verilog, you remember, if the statements written in the begin and end, those are the sequential statements. In any code, if you write some set of statements, okay, in the begin and end, all these statements are sequential statements. We know that if that a model contain n number of always, all will execute concurrently, but the statement written in the each and always will execute sequentially. So begin sum A XOR B, carry A and B. Directly we write this expression. So sum is equal A XOR B, carry is equal A and B, and end model. This is the simplest way to describe the off adder. Without knowing internal structure, how many gates, how they are connected, just I'll write an expression, okay, logic by using this XOR and operator. I hope you understood. So thumb rule here, that LHS should be reg type. You should declare those sum and carry as a reg because those are LHS signal variables here inside this always block. And the sensitivity list. So you should mention here. Whenever A or B changes, it will execute, then it calculate sum and carry. See another example, a full adder having a three inputs A comma B and C in sum and carry. Now here, how do I write a Verilog code for this simple full adder? Module name, port list A, B, C and sum and carry, and declare this as the input and declare this as the output. Input A comma B comma C. Output reg sum comma carry. So we are using these as a LHS in the procedure block. So you should be declared, those should be declared as a reg type. Remember this. Always at the rate a star. This is a compact way. This is a modern way to write a sensitivity list. It take automatically all the signals in this always block, okay, as a sensitivity list. Now it consider A or B or C. So we can write always at the rate A comma B comma C, or else you can write it automatically takes sensitivity list. It's a better way to write always block, especially this modeling style will used for combinational circuit design. So if always at the rate star means it take automatically all the sensitivity list signals which are the part of this always block. So begin, so carry comma sum is equal A plus B plus C. You are not worried about how many XOR gates there are, how many AND gates there are, how they are connected. Okay, we are not bothered about this internal structure. Just we'll write a simple expression like is in C code. In the C programming, write that, okay, A plus B plus C. Like same way we can write this. So I'll use some concatenate operator. So carry comma sum A equal to A plus B plus C and an end model. Already we discussed these operators, okay, how we are concatenating two signals like that, okay, two variables. So here the output is stored in the carry and sum. All are 1 bit, the output is a 2 bit, so 1 bit is sum and 1 bit is a carry. So if you see this another example, 2:1 mux having a 2 input and 1 selection line and 1 output. So now see, this is a truth table. If selection line is 0, then y is equal to I naught. If selection line is 1, then y is equal to, how do I write a Boolean expression? Like this. So simply y s bar I naught plus s into I1. So already we discussed this 2:1 mux many times. Now how do I write a Verilog code for this? In behavioral modeling, so module name and the ports output I naught I1 as are the input. Just you declare those as the inputs I naught I1 and s, and output reg y. You should declare input signal as a y type here, that output is a reg type because this y is used in the always block, that to LHS size. Clear? So always at the rate I naught or I1 or s. We can write I naught comma I1 comma s, or you can write I naught or I1 or s, or you can write a star, simply star, always at the rate star. In that case, it take automatically all sensitivities list. So always at the rate I naught or I1 or s, begin. If s is equal to 1, then y is equal to I1. Else y is equal to I naught. If s is equal to 1, then y is equal to I1. Else y is equal to I naught. The simple if else statement we use it to describe the 2:1 mux in a behavioral modeling style. So now see another example, 4:1 multiplexer. So these are the 4 inputs and 2 selection line outputs. So just you want to know a truth table, then by using the truth table directly we can write the behavioral modeling style. So now this is the truth table. So S1, S0 out, both are 0, out equal to I1, then 0, 1, out is equal to I1, 1 equal to 1, 0, then out equal to I2. So 1, 1, then out is equal to I3. So how do I write a Verilog code? Simply I'll use a case statements to describe this 4:1 multiplexer. Module name, here inputs I0, I1, I2, I3, and S0, S1 also input, both are declared as the input and wire. Then output is the reg type, then out. So always at the rate star, it will take all sensitive list automatically. So begin and end. So case. So S1 comma S0. So this is a concatenation. So this is a 2 bit. Even this S0, S1 is a 1 bit. Now I'm concatenating these two. Then it makes a 2 bit. Now this is S1 and S0. If S1, S0 both are 0, 0, 2 tick B 0, 0, then out equal to I0. If both are 0, okay, then out is equal to I0. If S1 is 0, S0 is 1, 0, 1, then out is equal to I1. Then if S1, S0 is 1, 0, then out is equal to I2. If S1, S0 is 1, 1, then out is equal to I3. Else, the default case, else, then out is equal to 0. You may get a doubt, sir, only we have 4 combination, why we'll get another? Maybe sometimes that selection line may be X or Z. In that case, that out is equal to 0. There's a simple way to describe the 4:1 mux using a case statement. In all these examples, what you observe, we have some always block. So we use a procedure block, especially always, to describe any model in a behavioral modeling style. In this always, we'll use some statements. Clear? That may be a procedural statement, maybe blocking statement, maybe non-blocking statement, some state construct like if else, or maybe case statements to describe the actual behavior of the circuit. I hope you understand. So how to write a behavioral modeling style, especially in Verilog, to describe the hardware. So just I'll show some examples. But if you want to describe any circuit behavior, if you want to design any digital system design using behavioral modeling, we should know what are the various blocking, non-blocking statement, and especially procedural blocks, always and initial. What are the statements inside that procedural block? Those are the procedural statement, blocking and non-blocking, and various like a conditional statement, if else, case, and else. So etc. We should know all these things. So in the coming lectures, I'll explain each and every concept individually. So I'll make a one video on initial and always. I'll make one more video on case, like that I'll explain. So one video on blocking and non-blocking statements. So here I want to just show. So if you want to describe any model in behavioral modeling, we'll use this procedure block always and initial. So I hope you understand this. Thank you very much.